Hello and welcome to the Building Embedded Control Systems webcast series. In this session we'll look at how to synchronize the movement of motors in 2 or more dimensions. Let's look at the agenda and content for this webcast. First we'll look at the meaning and the purpose of synchronized motion. Then we'll take a look at the considerations required for synchronizing motors. We'll look at some control system options for synchronized motion, and then we'll have a short demonstration of 2 synchronized steppers working together. First, a short introduction. We're from Synch Systems. We are a systems integrator for automated test, embedded control systems, and machine vision, headquartered in San Diego, California with 20 employees. We have a number of LabVIEW certified developers on staff, and we are an National Instruments Gold Alliance partner with the embedded control specialty, the electronic design specialty, and the machine vision specialty.
Synchronizing coordinated motion is often necessary for performing a number of specialized moves that we see in our daily lives. Whether it's a printing machine or some sort of milling or cutting machine doing shapes and letters, coordinated movement with other types of actions, in fact, such as cameras, dispensers, or signal acquisition or generation, is a very common requirement and requires a specialized control system. There are some considerations to be taken into account when choosing motors for synchronized movement. Firstly, they must be discrete moving motors with feedback, such as a stepper with an encoder or a servo motor. Next, they need to be a single control system coordinating all the movements between one or more motors, so that one control system decides where both motors are going. There needs to be some kind of an application on the control module choosing how and when to drive the stage movement, whether it's creating letters, angles, shapes, or dispensing material. And in some cases, the motion needs to be fast and needs to have something of a high resolution or high precision, such as microstepping. When it comes to control system requirements, we have the same basic requirements as we would with a stepper motor. In this case, though, we need a microprocessor that has to have the ability to do more complex mathematics, such as computing an arc, a spline, or sequencing a series of movements for the application. So in that case, we require a logic or an application that will determine the coordinated control, such as moving a crane to a location to pick up a part, or drawing an icon with a laser, in which case we have to move an XY motion of the laser or using mirrors. So therefore we also need fast, high-resolution I/O for managing other synchronized discrete steps or movements, such as controlling by position or velocity and keeping them in time with the encoder. And then in some cases we need custom or extra I/O to coordinate with dispensing or measurements or whatever the application requires.
So that's where the NI LabVIEW Rio technology platform comes into play again. You can see it comes in a variety of shapes and sizes, but they all contain the same basic Rio architecture, depending on which platform works the best or which setup works the best for each application. They all contain a microprocessor, an FPGA, and the FPGA can be connected to a variety of different inputs and outputs, such as analog, digital, or your own custom I/O. And that's the meaning of the Rio architecture, meaning reconfigurable I/O. So depending on how many steppers or what kinds of steppers and servos you have and how they're controlled, the Rio platform is the perfect platform for doing just this kind of motion control. So here we have a small demonstration of a synchronized motion system where multiple stages or stepper motors are being controlled from a single Rio platform. It could easily have been compact Rio, but in this case we're showing a single board Rio in an OEM customer application. Here we have a single board Rio with a Circuflex board wired to a connector board which is controlling, in this case, as many as 11 coordinated steppers, all doing different purposes, such as moving a part that's a workpiece, moving a dispensing head, and then applying different liquids or gels to the workpiece. It has a real-time application. Its purpose for the real-time part is for converting a sequence of moves, or the plan, the work sequence plan, into multiple move profiles. And then an FPGA application, which takes those profiles, turns them into velocity or position moves, and then converts those into synchronized pulse trains, which is basically a series of steps that tell the steppers when to move and coordinates them so that they work together to create such things as a correctly shaped circle, or to move and dispense in coordination. In this case, we made heavy use of anti-soft motion, which helped us coordinate quite a lot of complicated tasks, including coordinating multiple axes and creating coordinate systems, coordinating gear ratios with 2 motors that don't move in the same ratio, and coordinating accelerations and decelerations of steppers that needed to start and stop over different distances, all starting and stopping at the same time. So to review, we've looked at synchronized motion done with precise time signals. That's what's required, depending on the application needs, that's what's required for synchronized motion. We've observed that the Rio platform is perfect for providing all the timing and computation needs along with reconfigurable I/O depending on the requirements of the application. We've looked at our CircuFlex adapters and the control module which provides the synchronized motion out to the stepper amplifiers and drivers and the coordinated I/O that goes with it, in this case for doing dispensing and other sensors. And we looked at how the NI soft motion platform and software helped us make a lot of complicated coordination between all this movement quite a lot simpler to program. And of course, in this case, there was custom software that was necessary to be written for the application so that it would perform a sequence of steps in the application of what this product does. So thank you for watching. To learn more about NI Alliance Partners, please visit ni.com/partners. And to view additional webcasts in this series, please visit ni.com/buildcontrolsystems. Thanks again.